Hello. This time we are going to present a problem situation applying the concept of greatest common factor, also known as GCF. This is teacher Omar Naranjo, math teacher of 6th grade in New Cambridge School. So let's begin with the problem. Well, in this case, the problem states the following. There is a grocery store which is making identical fruit baskets. The store has 240 bananas, 72 oranges, and 144 apples. There are two questions in this problem. We have to find the greatest number of fruit baskets the store can make if each basket has to have the same number of each kind of fruit. And the second question is, how many pieces of each type of fruit are in each basket? Maybe you are a little bit confused, so we are going to explain and understand the problem with a more simple situation. Now, let's suppose that you have 8 bananas, 12 apples, and 4 oranges, which is a, more simple number to handle of each kind. We are going to try to distribute our fruits in the baskets in equal amounts. When we have one basket, it means that we are going to put all the fruits inside the basket. So we know that in one basket, we have 8 bananas, 12 apples, and 4 oranges. But what if we use 2 baskets? Can we do an equal distribution? Let's see. So now let's present it with 2 baskets. So in 2 baskets, we can use 4 bananas per basket, 6 apples per basket, and 2 oranges per basket, which means that we can make an equal distribution with 2 baskets. But we want to know if we can use more baskets. Let's try with 3 baskets. In this case, we see something interesting. That number 12, it means that 12 apples is the only number that is divisible by 3. On the other hand, 8 and 4, representing the number of bananas and oranges, is not possible because 4 and 8 are not multiples of 3. Means they cannot be divisible by 3, so we cannot use 3 baskets to do an equal distribution. Now let's try with one more. Let's try this example with 4 baskets. In this case, we have the following situation. Let's see. In 4 baskets, you can put 2 bananas per basket. That's an equal distribution. 3 apples per basket, again an equal distribution. And finally, 1 orange per basket. And that's it. We can do it. It means that up to this point, the highest amount of baskets we can use is 4 for this example. But the question is, can we use more than 4 baskets? Well, it's not possible to use more baskets because we cannot distribute any more oranges. Well, but now we have to move on to the original problem. In this case, we don't have so little quantities or amounts of bananas, oranges, and apples. In our original problem, we have 240 bananas, 72 oranges, and 144 apples. Well, now this is too much, I think. And if you were thinking to do what we just did in the simple example, you will probably go nuts. So let's try a different option. And in this case, we are going to present GCF to find the highest amount of baskets we can use to have an equal distribution of fruits of each kind. Which means that we are going to take, firstly, the 3 numbers we have, 240, 72, and 144, representing the number of bananas, oranges, and apples we have. And we are going to start doing the prime factorization again, but with the 3 numbers at the same time. We trace the line of prime factorization and we notice that the 3 numbers are divisible by 2. So we can begin with this prime number. Doing that division, we have 120, 36, and 72. Now, I want you to notice something important, so I'm going to use this. Well, the three numbers now are divisible by 2 again, so we can continue using number 2. Now, the division is like this: 120, 36, and 72 divided by number 2. So, before I show it, you should know. This is it: 60, 18, and 36. As you may notice, the three numbers are also divisible by 2, so yes, you can continue using number 2. This division results like this: 30, 9, it's in red, now you will see, and 18. There is something different in this case, because you will have the question, can I still using number 2 when we are going to find the GCF of 2 or 3 or more numbers? In this case, compared to LCM, or the least common multiple, we cannot continue using number 2. We need to find a number that can divide the three numbers at the same time. As you can see, 30 is a multiple of 3, 9 is a multiple of 3, and 18 is a multiple of 3. So we can use now number 3. So now the division comes like this: 30 in 3 is 10, 9 in 3 is 3, and 18 in 3 is 6, as you can see here. This is 10, 3, and 6. That's it. Now we have numbers 10, 3, and 6. If you think there is no number that can divide these three numbers, so what can we do? Well, this is the moment when we finish and we just have to move to express the GCF of 240, 72, and 144. This is the product of the numbers we have here. So let's do it. 2 times 2 times 2, it means 3 times 3. So we have 2 cubed times 3, and this is 2 cubed is 8 multiplied by 3, and our final result is 24. Well, but what is 24? What does it mean? Well, remember the question, the first question of our problem? We wanted to find the highest amount of baskets we can use to make an equal distribution. So 24 means the highest amount of baskets we can use to equally distribute the fruits we have. Okay, now the second question comes. How many fruits of each kind will there be in each basket? Well, remember we had 240 bananas. Since we had 24 baskets, because this is the highest amount of baskets we may have, we just do the division and you will come that you will have 10 bananas per basket. So we can do the same in the other two fruits. We have 72 oranges in 24 baskets, which means that you are going to have 3 oranges per basket. And finally, 144 apples in 24 baskets. Again, you do the division and you find that you will have 6 apples per basket. And this is one of the applications of greatest common factor. Remember, when you are asked to find the highest amount of something to have an equal distribution, use GCF, or greatest common factor. Well, that's it. Thank you.